Now, in this video, we will derive the relation between the torque and shear stress in the hollow circular shaft. So here we can consider a circular hollow shaft having the internal radius of Ra and the external radius of R0, or internal diameter Di and the external diameter as D0. So consider a hollow shaft of outer diameter D0 and inner diameter Di subjected to torque T. The maximum torque transmitted by the hollow shaft is obtained from the maximum shear stress. So now consider an elementary circular ring of dr, which is the thickness and the radial thickness of dr, and at a radius of small r from the center of the shaft, which is as shown in this figure. So when you're considering that, what is torque? Torque will be mt, or T will be equal to applied torque, and small q is the shear stress at the radius r from the center, and tau max or tau will be equal to the maximum shear stress at the outer surface of the hollow shaft, where R0 is the outer radius of the shaft and Ra is the inner radius of the shaft. Therefore, area of the elementary circular ring will be equal to 2 pi r into dr. So from the equation 4, that is tau by r is equal to g into theta by L will be equal to small q by small r. So where from equation 4, what happens? Tau by R0, because that is the radius of the external radius, which is R0, will be equal to small q by r, which will be shear stress at radius small r will be equal to at radius small r, which is q, will be equal to tau into small r by capital R0. Therefore, shear force on the elementary circular ring will be equal to, that is dF, which is equal to shear stress into the area of the ring, which is A. So that is tau, substitute that tau by R0 into 2 pi r into dr into area of the ring, which is R. What will going to be the shear stress, which is tau by R0 into R into dA, shear stress on the area of the ring, which will be 2 pi r into dr into R. So therefore, you will going to get that value as, so what you are getting, this R is nothing but tau by R0 into 2 pi r into dr into small r. So tau by R0 into 2 pi r square into dr, which will be equal to torque on the elementary circular ring dt will be equal to df into distance of the ring from the center. So that will be equal to tau by R0 into 2 pi r square into dr into r. So you take it, multiply that tau by R0 into 2 pi r cube into dr. So torque T will be equal to integral of Ra by R0, because it is the hollow circular shaft, which is dt. So Ra by R0, integral of Ra to R0 is into tau by R0 into 2 pi r cube into dr. So take out tau by R0 into 2 pi into the common outside the integral sign because of the constant, which will be integral of Ra by R0 into r cube into dr, because here R0 is a constant for a circular hollow shaft, and shear stress is the tau is the shear stress for that material. Given is constant. 2 pi, of course, is a constant. Integral of Ra by R0 into r cube into dr, which will be equal to tau by R0 into 2 pi into R0 to the power of 4 minus Ri to the power of 4 by 2. So that will be equal to, on simplification, tau by R0 into, put the R0 is equal to D0 by 2. So R0 D0 by 2 means it will going to be 16. 2 to the power of 4 is 16 multiplied by 2, which will going to be 32. So pi by 32 into D0 to the power of 4 minus Di to the power of 4. If R0 is equal to D0 by 2, and Ra will be equal to Di by 2. So on simplification, T is equal to tau by R0 into Jp, where Jp is the polar moment of inertia, that is pi by 32 into D0 to the power of 4 minus Di to the power of 4. So substitute that T by Jp is equal to tau by R0, which is called this equation as 8 because of the cross multiplication between this torque. T by Jp will be equal to tau by R0. So therefore, the maximum shear stress, which is tau or tau max, will be equal to T into R0 by Jp, which will be equal to T into What is R naught, which is d naught by 2 by pi by 32 into d naught to the power of 4 by di to the power of 4. So that will be equal to 16 into t into d naught divided by pi into d naught to the power of 4 minus di to the power of 4. Call this equation as 9. So this is how you will be able to derive the expression for the hollow shaft of maximum shear stress. Thank you.